So this mode of sending photons either with vertically polarized photon or horizontally polarized photon, we call this a VH mode of communication. Okay? There is another mode that they can communicate with, okay, that when Alice generates the photon, she makes sure that it is 45 degrees polarized, okay, or minus 45 degrees polarized. This is vertically polarized or horizontally polarized. Okay. There's another mode called it 45 degrees mode. Okay, 45 degrees mode. Then you essentially have plus 45 degrees polarization and minus 45 degrees polarization. Okay? And in this mode, the photon is polarized in this direction. In the other mode, the photon is polarized in this direction. And Alice and Bob can generate photons in this mode by passing the photons through an optical polarizer. If they align the polarizer to be 45 degrees, the photon that goes through has to be polarized in that direction after passing through the polarizer. Before the polarizer, the photon can be in the linear superposition of these two states, okay? And then after you pass through the polarizer by quantum interpretation, the polarizer is an experiment. It collapses the photon to the 45 degree state. Okay, so all photons that passes through a 45 degree polarizer will be photon in the 45 degree state. That is the canon of quantum interpretation. Okay, by having the photon goes through the polarizer, it's very much like the Stern-Gerlach experiment that early people found. Either the spin is up polarized or down polarized in the Stern-Gerlach experiment. Probably remember this. Okay. So if Alice sends out a photon that is vertically polarized, by making sure that the photon goes through a vertically polarized vertical polarizer. And then if Bob receives it with a 45 degrees polarizer, okay, then Bob would only receive that 50% of the time correctly, that he would see a photon going through his polarizer. So if you have a transmitter that is transmitting a vertical polarization, and if Bob receives it with a 45 degrees polarizer, he will only receive the photon or see a photon going through his polarizer 45 degrees at a time, because of this principle that the 45 degree state is a linear superposition of the horizontal state plus the vertical state. Okay, the plus 45 degree state, a photon polarized in the plus 45 degree state is a linear superposition of the horizontal state and the vertical state. Okay, we all know this. Because if the particle is oscillating like this, if it's a quantum particle, it's the linear superposition of the horizontally oscillating particle plus the vertically oscillating particle. Okay? And then minus 45 degrees photon is also equal to this thing. From this, we can easily gather the converse. Okay? From this, we can invert this relationship and say that the horizontally polarized photon is a linear superposition of a 45 degrees photon plus a minus 45 degrees photon. Okay? And that the vertically polarized photon is also a linear superposition of these two states of photons, and that would be plus 45 degrees minus 45 degrees. Okay? So if Alice sends out a vertically polarized photon, you can regard the photon to be a linear superposition of 45 degree state and minus 45 degree state. And if Bob receives it with the 45 degrees polarizer, okay, with one of these 45 degrees polarizer, he will only see a photon passing through his polarizer 50% of the time. The other 50% of the time, the photon is polarized in this state and cannot pass through his polarizer. Okay. All these are quantum mechanical interpretation of a photon state. These are not classical at all. Okay. It's one photon being decomposed into two states. Okay. So, if Alice decides to send his photons randomly, sometimes he will send it vertically polarized, sometimes he will use the VH mode. Okay, he will use the VH mode for transmission. Okay, she would either send the photons out vertically polarized or horizontally polarized. And sometimes she switches to this mode. Alice just want to switch to these two modes of transmission. Okay? And Bob doesn't know how Alice is sending out her photon. It's either in the VH mode, vertically polarized photon and horizontally polarized photon, or she used the 45 degrees mode. Okay? One would mean this and then 0 would mean that. The other one is 1 would mean this, 0 would mean that. Okay? And Bob doesn't know. Bob also aligns his receiving polarizer randomly. Sometimes using the VH mode to receive, sometimes using the 45 degrees mode to receive. So if both of them do it randomly, equally distributed between the two modes, okay, when would they use the same mode for transmission and reception? 50%. Half of the time they will have their polarizers aligned correctly. Right? The other half of the time they are off. If they equally distribute the transmission mode, if Alice equally distribute the transmission mode between these two, and then Bob equally distribute his receiving mode within these two, only 50% of the time they are aligned correctly. Okay, aligned correctly, and if they are aligned correctly, then all the ones and zeros will be transmitted and received correctly. Okay, the other 50% of the time, the ones and zeros are received correctly, always wrong, or part of them is wrong. Half of them, right? So 50% correct transmission. This is aligned correctly. So 50% of the data is transmitted correctly, but the other 50% they are aligned incorrectly. But if they are aligned incorrectly, only half of the time the transmission is right. Okay, if Alice sends in the vertical mode and Bob receives in the 45 degrees mode, okay, and then he will find that only half the time he will receive a 1, and the other time he will receive a wrong 0. Okay, so of this 50% time, so 25% correct, 25% wrong. Okay, this is misaligned polarizer. And we misaligned polarizers. Okay? So if now this is a very simple encryption scheme, if now after they transmit a whole bunch of data using this random scheme, okay, after that they make a phone call and talk to each other and compare their data that they have transmitted using this optical system, photon communication system. And they found that 75% of the time their data is correct. Okay? Then they say that the system is working correctly as predicted. Okay? But if somebody eavesdrops, you'll find that this percentage correction will be corrupted. Okay, we'll come back after coffee break to if there's an eavesdropper, okay, you have Alice and Bob, and the third person is Eve. And then Eve eavesdrop. But eavesdrop is spelled differently. Eavesdrop. If she eavesdrops and tries to interfere and intervene with this optical communication system, you'll find that this percentage ratio will be wrong. Okay, we'll come back after coffee break to look at what if Eve eavesdrops on the communication system. Okay? And if somebody tries to intervene, he or she will be discovered in this quantum communication system. Okay, are there any questions so far before we take a coffee break? Okay, we take a coffee break and see what Eve does to the system.